everyone, Mrs. Basega here. For this part of the class, you will absolutely need your notebook. I have some definitions that you need to write down and some key steps to problem solving that you're going to want to be able to refer back to. Especially if you didn't optionally pick up a textbook, you're going to want these notes. So grab a notebook. Go, 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 go! First off, I want to make sure we can tell the difference between the quantity of a force and what's called a net force. So first off, a force is an interaction between two objects that could cause a change in motion. A gravitational force acting on its own is a force. Friction is a force. But net force is the sum of all the forces acting on an object. Net force is the total if we add up all the forces acting on an object, assuming that some cancel each other out. You can have an object with zero net force that has tons of forces acting upon it. So let's show you what I mean. First off, we're going to have to talk about scalar sum. If net force is a vector sum, then what's the difference? So, this is worth writing down. A scalar sum, that is just addition as you already know it. Scalars are quantities without direction, like time or mass or volume or apples or money or bags of popcorn. Scalar addition is just regular addition. 3 liters of soda plus 1 liter of water is 4 liters of total disappointment. For scalars, you can just add up the numbers. I can never have a negative liter of water. There's no fluid I could pour into the soda to end up with only 2 liters of fluid left. It doesn't cancel each other out because scalars don't have direction. Now vectors are different. Vectors, like this vector, have magnitude and direction.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ow! It's so difficult sometimes to get the piranha back inside.
So, a vector sum, then. Vectors are quantities with magnitude and direction. But because they have directions, the directions can cancel out. This is used for quantities like displacement, velocity, force, acceleration, momentum, impulse, magnetic field, electric field. There's a whole bunch, guys. But you know what? You and I, let's concentrate on displacement and force. So here's a displacement example. If you walk 5 meters to the right, then 2 meters to the left, how far are you from where you started? Well, that's not so bad. That's just 3 meters. A vector sum identifies some distances or some forces as positive and others as negative depending on their direction. In my head, I automatically call right positive, then I subtracted 2 from the left as negative, so I get 3 meters total. Direction-wise, we do math conventions. X refers to right and left, just like it does in math. Y refers to up and down, just like it does in math. Positive is going to be defined as either right or up, and negative is going to be either left or down, just like in math. So here's how we do net force then. First off, when you want to calculate net force, it's good to have a free body diagram already drawn, like the one on the right here. Though I would critique the one on the right here that they should be drawing their object as a dot, not a box. But okay. We identify the signs as positive and negative. Tension is going upward, I would call that positive 1,200, and gravity is negative 800. I'm going to add all the forces in the x direction. Done. I'm going to add all the forces in the y direction. And that is it. So how this looks is 1,200 up, that's positive, minus 800 down, because that gravity is negative, gives me a force of 400 newtons up. As a result, I know this object is not in equilibrium. The forces are unbalanced, so it's not equal, not in equilibrium, and thus the object must be accelerating upwards. That extra 400 newtons of force is causing the object to accelerate up. This might be something like an elevator, where tension in the elevator cable is greater than gravity pulling it down, so it accelerates upward. Example 2. We have a positive 600 for air resistance because it's going up, negative 800 for gravity because gravity is pulling down. That gives me a net force of negative 200 newtons down. If you want, you could just call this negative 200 newtons or 200 newtons down, and I will accept it either way. I don't see this as a double negative scenario. So negative and down don't cancel out here. So you can include both if you want. I know this object is not in equilibrium. That extra 200 newtons of force is accelerating this object to the ground. Maybe this is something like a parachuter. They're accelerating towards the ground, and the parachute slows them down. What about this one? This one has forces in both the x and y direction, but it's still not that bad. I'm doing the same logic, but just twice. 50 newtons up from normal force cancels 50 newtons down from gravitational force, so this object is not accelerating up or down in the y direction. This 20 newtons left from the friction force is unbalanced. There's no other force on the right, so this object accelerates left, and it is not in equilibrium. So what do we mean equilibrium? Equilibrium means that the force in the y direction cancels, like normal and gravity in this scenario. Friction and applied cancel, like applied is 5 and friction is 5, so they're 0. Because the net force is 0 in both the x and y directions, this object is in equilibrium, and it is not accelerating. So I want you to ask yourself when we're figuring out acceleration, is the net force that I just calculated, is the number 0? Hey, if it is, the forces are balanced. Think of it as there's no extra force in any direction to cause that object to change its motion. So it's not going to accelerate. However, if you have a number that's not 0, any number that's not 0, then your object is not in equilibrium. And whatever direction that extra net force is, the leftover force, that extra force is causing the object to accelerate. And it's going to accelerate in the same direction as whatever the net force was. So if you have extra applied force causing a net force to the right, your object accelerates to the right. So one more example before you try this on your own. What is the net force in this scenario? On object D, I have positive 5 newtons to the right, positive 3 newtons to the right, subtracting 10 newtons to the left, which gives me negative 3 newtons to the left. This object is not in equilibrium, and so it is accelerating in the direction of net force. It accelerates to the left. Now, let's try this on your own. Good luck!